Hypothalamus Artificial Intelligence, HI, presents the short lecture. The full artificial intelligence. The capacity of artificial intelligence can be measured by the number and type of questions it can answer. The methodology proposed by HI seeks to increase the coverage of artificial intelligence. HI considers that today artificial intelligence is generative pre-trained transformers and mathematical programming. This is the main theme of HI's research. Lecture prepared by Jesus Velasquez Bermudez. The partial artificial intelligence. Most people, including many scientists and experts in artificial intelligence, think that it is limited to generative pre-trained transformers models. In this way, this vision of AI has become popular. Today, GPT-like commercial products are synonymous with artificial intelligence, but GPT's coverage is limited regarding all the questions that AI should answer. McCullough and Pitt's theory, which has existed for more than 80 years, has proven to be totally successful, and based on it the current state of artificial intelligence has been reached, which we could say are GPT methodologies. But their coverage is not complete. However, Velasquez Bermudez's work, spanning 35 years of research and technological development, has resulted in artificial brains, which are a new way of thinking about artificial intelligence. In 1943, Warren McCulloch and Walter Pitts created the concept of artificial neural networks. They published the article, A Logical Calculation of the Ideas Immanent in Nervous Activity. McCulloch and Pitts tried to explain how the brain could produce highly complex patterns, by using many basic cells that are connected. Neural networks were growing, and in practice they took the name of artificial intelligence. They were also called machine learning. The growth of artificial neural networks is due to the great growth of computational power, and not to a paradigm shift, which after 80 years should have already occurred. This change started at the beginning of Industry 4.0, with the introduction of multi-problem mathematical models, which in 2020 evolved into artificial brains. Artificial General Intelligence, AGI, is a hypothetical type of highly autonomous artificial intelligence, AAI, that would match, or exceed, human capabilities in most, or all, economically valuable cognitive work. It contrasts with narrow AI, which is limited to specific tasks. Super Artificial Intelligence, ASI, on the other hand, refers to AGI that far exceeds human cognitive capabilities. The creation of AGI is a primary goal of AI research in companies like OpenAI, Google, and Meta. A 2020 survey identified 72 active AGI research and development projects in 37 countries. The timeline for achieving AGI remains a topic of ongoing debate. As of 2023, some argue that it may be possible in years or decades, others argue that it could take a century or more, a minority believes that it may never be achieved, and another minority claims that it is already here. The Nobel laureate in physics for his work in AI, Geoffrey Hinton, has expressed concern about the rapid progress towards AGI, suggesting that it could be achieved sooner than many expect. There is debate about the exact definition of AGI and whether modern LLMs, like GPT-4, are early forms of AGI. There is controversy over whether AGI poses an existential risk. Many AI experts have stated that mitigating the risk of human extinction posed by AGI should be a global priority. Others consider that the development of AGI is too remote to think about such a risk. In 2024, John Hopfield and Geoffrey Hinton were awarded the Nobel Prize in Physics for their foundational contributions to machine learning, particularly through their work on artificial neural networks. Currently, the search for a solution for AGI is based on artificial neural networks, based on the fundamentals of GPT. Mathematical programming has benefited from computational power, but not as much as artificial neural networks. This is due to the investment that humanity has made in GPT models. Danzig's work gave rise to mathematical programming. Although mathematical programming is clearly a way to provide artificial intelligence to computers, and it grew much faster than the so-called artificial intelligence based on neural networks, to date mathematical programming is considered by almost all users, and by many scientists, as a methodology that is not part of artificial intelligence. There is no awareness that it is necessary for humanity, since its function is to optimize decisions. Artificial neural networks have concentrated on trying to mimic the way humans detect patterns. It has been a totally successful process. However, they cannot explain what will happen to human decisions. This is because the basic GPT model corresponds to a predictive analytics model, of the regression type, and that when the number of parameters that are estimated increases, the essence of the model does not change. The model takes historical data, which explain the past, but with a low extrapolation capacity, which can only be improved if mathematical models that describe the process in the future are included. Artificial Brain 6.0? Velasquez, in 2021, published on SSRN, the paper Artificial Hypothalamus, Artificial Intelligence and Mathematical Programming Integration, in which the foundations of artificial brains, and more specifically of the hypothalamus, are laid. The article, and others later, carefully studies the relationships between the structures of the neocortex, with those formed when a mathematical problem is atomized, to use large-scale optimization methodologies, oriented to the partitioning and decomposition of systems, and they define the artificial brain in semi-detail. This is a disruptive vision of artificial intelligence, considering the power of computers, the evolution of mathematics, and the Internet of Things. This conference explains in a summarized way this evolution, based on the current state of AI. A complementary document is Artificial Brains, Augmented Artificial Intelligence, Artificial Neocortex plus Artificial Hypothalamus plus Artificial Hippocampus, published in 2022. Artificial Brains is a disruptive modeling methodologies for Industry 4.0, based on the integration of artificial intelligence and mathematical programming. Its formalization will take place from 2021. The science of decision-making using digital computers emerged in 1947 and can be attributed to George Dantzig. The AI in which artificial brains are located, High calls it artificial intelligence for decision-making. The image shows a close-up of the human brain showing the activation of neurons and neuronal extensions of the limbic system, mammillary pituitary gland, amygdala, thalamus, cingulate gyrus, corpus callosum, hypothalamus. This indicates that the human brain is composed of groups of neurons which in turn are composed of groups of lower-level neurons, or individual basic neurons, called by High the atoms of the system. The central idea of the artificial brain is to build an artificial intelligence that mimics the human brain, leaving aside the approach of trying to represent the entire brain using a single network of artificial neurons. High believes that the creator of the human brain conceived it as the integration of three main organs, or systems: neocortex, hypothalamus and hippocampus. The hypothalamus is part of the thalamus. Every man can be, if he sets his mind to it, a sculptor of his own brain. This famous phrase by Don Santiago Ramon y Cajal has guided generations of neuroscientists like a beacon. For more than a century, science has considered the cranial brain as the only center of neuronal complexity, relegating the rest of the organs to the noble task of fulfilling their functions. However, modern research, armed with tools that the master could hardly dream of, but whose arrival he prophesied, reveals to us that organs do not only obey, they also feel, process and decide. It is as if each one has its own brain of neurons, and that these neurons connect all the organs. The components of the human brain have at least two levels. On the first level, there are the main organs such as the neocortex, the hypothalamus, and the hippocampus, and on a second level, the neurons that make the main organs. The image shows on the left, the motor neuron of the spinal cord, on the center, the neurons of the pyramidal cell of the hippocampus, and on the right, the neurons of the pyramidal cell of the cerebral cortex. We could say that in the human brain we have two types of organs: physical organs that are in the cranial brain, and virtual organs that exist, make decisions, participate in the life of the human being, but we cannot locate them in the cranial brain. The human intelligence does not live in a single intelligent zone, but arises from the efficient and flexible way in which all brain networks communicate and coordinate with each other. While historical theories attempted to link higher IQ strictly to localized areas, or total brain volume, modern neuroscience emphasizes that complete brain coordination, dynamic reprogramming, and signal conduction speed are the true drivers of intellectual ability. Human intelligence is not localized to a single isolated region of the brain but arises from the dynamic interaction of globally distributed neural networks. While historical views attempted to identify cognitive traits in specific cortical areas, modern connectomics and neuroimaging demonstrate that general intelligence depends on the brain's ability to balance local specialization with global integration. Fundamental conclusions of modern connectomics. Strong and weak connections matter. Predictive modeling of the connectome reveals that high intelligence depends on both major structural pathways and minor, flexible functional pathways. Neuroplasticity limits strict mapping. If a central region is damaged, nearby areas or alternate white matter pathways adapt to recover cognitive functions, demonstrating that the brain is a complex adaptive system and not a hardwired computer. Key takeaways from modern connectomics: strong and weak connections matter. Predictive connectome modeling reveals that high intelligence relies on both major structural tracks and minor, flexible functional paths. Neuroplasticity limits strict mapping. If a core region is damaged, nearby areas or alternative white matter pathways adapt to recover cognitive functions, proving the brain is a complex adaptive system rather than a hardwired computer. Human intelligence has evolved along with human beings. To understand this process, Hy describes human intelligence as composed of three types of intelligences. They are associated with the evolution of intelligence over time, and throughout humanity at any time. Mental intelligence. The fundamental question for mental intelligence is pattern recognition. Creative intelligence. The fundamental issue for creative intelligence is the achievement of scientific discoveries. And mathematical intelligence. The fundamental issue for mathematical intelligence is to solve real-life problems. Human intelligences must follow a logical cycle to achieve their maximum performance. Every human being is born with an innate mental intelligence that allows to identify patterns and begin the process of acquiring knowledge. To generate knowledge, human beings must possess and activate creative intelligence. With evolution, this intelligence has become fundamental for scientists and artists. Mathematical intelligence is the name that points the way to use the knowledge generated by the creative intelligence of scientists. It is responsible for technological development, the results of which enrich the knowledge of creative intelligence. Artificial intelligence of humans beings. Instead of building autonomous systems that mimic or completely replace human workers, AI uses machine learning, deep learning, and advanced probabilistic analysis to extend human cognitive performance. Industry 6.0 marks the transition to a paradigm in which technology not only automates but also integrates biologically and cognitively with humans. While Industry 4.0 focused on digitalization and Industry 5.0 brought human collaboration back to the forefront, Industry 6.0 introduces living, self-regenerative, and deeply ethical industrial ecosystems. Currently, the situation is that from Industry 5.0, artificial intelligences become part of the human being, as one more intelligence that must be managed. Artificial intelligences today communicate by phone, but it's not surprising that in just a few years they can reside in a nano CPU, like an implant in humans. Mental intelligence underpins the mental models that every human being requires to start making their decisions. Human knowledge is supported by three types of intelligences. Mental intelligence. It is the abstraction or conception of what is perceived by individuals about a given issue or problem. Mental models are constructed with the knowledge, experiences, assumptions, perceptions, intuitions, informal inductions, deductions, and values of the individual. They are elementary models that are not exposed in public and therefore have a validity limited to the individual. They have their origin in the evolution of the human being, hominization, from the most primitive ancestors, Australopithecus, to the appearance of our species as we know it today, Homo sapiens. All human beings manage mental models, very quick to solve, and, in their absence, easily copy themselves from a more influential individual, and more recently, are implanted in human beings through the ochlocracy of mental models distributed by social networks. When intelligence works under this model, we will call it mental intelligence. which exists and develops in all humans. Mental intelligence and pattern recognition. Mental model is oriented to identify patterns, its foundations are not mathematical, and respond to data processing and evaluation of eventual and systematic experiences. It is based on good practices. Pattern recognition is a data analysis method that uses machine artificial intelligence algorithms to automatically recognize patterns and regularities in data. This data can be anything from text and images to sounds, or other definable qualities. Pattern recognition systems can recognize familiar patterns quickly and accurately. Pattern recognition is the activity that most performs the human being, for example, identifies images of people, foods, hydroclimatic conditions, traffic conditions, texts, sounds, and etc. All this with the aim of establishing the conditions of the environment, in the past, the present, and the future, and based on this knowledge make decisions. How the brain identifies patterns is not properly known, but it is mimicked by traditional artificial intelligence. Then, the starting point of the name of artificial intelligence is associated to the pattern recognition. Today, the association is direct, and it seems that artificial intelligence is reduced to this function of the human brain, what has concentrated great amount of scientific research in working in this direction, forgetting other human brain functions. It seems that artificial intelligence is reduced to the emulation of mental intelligence, whose function is little known and explained. That is why it is known by scientists that neural networks can predict how a system will behave, but that in general the parameters found cannot be explained, they have no clear content, just as the humans cannot explain how this function works in the human brain. But this approach cannot be said to have been unsuccessful, as it effectively and massively replaces activities that ordinary humans did not think machines could perform. At first, neural networks were aimed at finding ways of connectivity of artificial neurons, seeking to improve the results of prediction. Something like a statistical model in which many algebraic models are tested, until a good solution is found. Little has evolved to try to explain content in this connectivity. This is the case with GPT. Pattern recognition is a basic human skill, for which we have no explanation. William Gibson quote, "Homo sapiens is about pattern recognition," he says. Both a gift and a trap. The essence of the so-called artificial intelligence is mental intelligence represented from the study of biological neurons, to emulate and surpass human pattern recognition. Normally, pattern identification is done by means of neuronal networks. Creative intelligence is the fundamental basis for the development of mathematical theories that support mathematical models. For this is an area of knowledge that is still unknown. To evolve from mental intelligence to mathematical intelligence, the human being requires another type of intelligence that allows him to perform the analyses to understand and discover the models that govern the universe that is written in the language of mathematics. Galileo Galilei, we will call this intelligence analytical creative intelligence. This intelligence can be considered as the highest level of human intelligence, since it is what allows to grow in the discovery of mathematical laws, and in general new knowledge, which is the engine of the scientific and technologic of humanity. In practice, very few humans have this ability and discipline. Proof of the above is the speed with which we produce knowledge. It took many centuries, hundreds, to produce algebra, but mathematical knowledge every day occurs faster, and extends its borders. For example, since 1947, with the appearance of the digital computer, a new science has been created: mathematics for computers, first monoprocessors, today parallels. This must be part of the artificial intelligence of the future. When the previous trend changes, humanity will have begun its disappearance process. Scientific thought. A scientist thinks critically, questioning the established and using the scientific method to systematically investigate the world, seeking explanations based on observation, experimentation, evidence, and logical reasoning. This way of thinking is characterized by curiosity, skepticism toward unfounded conclusions, openness to new evidence, and collaboration with others to generate verifiable knowledge not accepted by mere authority or common thinking. A scientist is characterized by the ability to ask questions about the why of phenomena and seek answers, which drives research, based on the systematic collection of data through observation and conducting experiments to test their interpretations of reality. Scientific conclusions must be supported by verifiable evidence and objective data that others can verify. He uses logic to associate concepts, generate new ideas and order knowledge into coherent theories. The scientific method is a systematic and objective process for acquiring new knowledge, which consists of observing a phenomenon, formulating a hypothesis, designing and conducting experiments to test it, analyzing the data, and finally reaching a conclusion. The main characteristics of this method are the falsifiability and reproducibility of the results, which allows other scientists to verify the findings and expand knowledge. The phases of the scientific method include observation, research, experimentation, and data analysis. The most important action is the formulation of hypotheses by finding a tentative assumption or explanation for the observed phenomenon. The conclusion of each step will be to determine whether the hypothesis is valid or not, based on the analysis of the data. If the hypothesis fails the test, the hypothesis must be changed, which involves change the basic theory. This means changing the mathematical model that explains the process, or change or increase experiments. If you want a cognitive robot to mimic a scientist's creative intelligence, which is equivalent to artificial general intelligence, AGI, you need to teach it the principles of scientific thinking and the process of the scientific method. Predictive intelligence like GPT does not have the ability to implement AGI. Those who have chosen this option are going down the wrong path. Mathematical intelligence underpins the mathematical models that some humans develop to make their decisions. Second, mathematical model is a scientific representation which make use of mathematical language to describe or to explain the portion of reality that is of particular interest to an individual. It is the result of the research carried out by certain humans. The mathematical models are growing as analytical tools that provide greater processing speed to the investigation. For its understanding requires formal training in mathematics and in the science being modeled. These models increase the intelligence of human beings, creating large differences, chasms, between them. When intelligence works under this model, we will call it mathematical intelligence. This ability to understand mathematics, and to handle it, does not extend to all humans. It is necessary to acquire knowledge and experience, to handle this intelligence properly. At present, its development is directly related to the ability to handle computational and mathematical technologies. Mathematical intelligence and decision-making. Decision-making process is the final objective of any person or organization, which seeks to make the best decisions from its point of view, its criterion. This process, when carried out in real time, requires a great capacity for mathematical calculation, to handle the complexity of the real world, which increases over time, since the universe increases its entropy at each moment. When humanity began its evolution, it only had mental models to support its decisions, which seriously limited the speed of the evolution of the species, due to the little, almost zero, capacity of mental models, which led the human being to make decisions with very few calculations, or without them. Thanks to analytical intelligence, human beings developed their mathematical intelligence, which has led us to Industry 4.0. Since the creation of AI, and the advent of the computer, it can be said that predictive methodologies displaced prescriptive ones, in what was called artificial intelligence. For the convenience of the reader, decision-making artificial intelligence, DMAI, will be presented in comparison to traditional artificial intelligence. The first big difference is that DMAI is based on the study of mathematical intelligence, which focuses on the representation of the physical world through algebraic formulas, or through differential calculus, and solves problems using exact mathematical algorithms, aimed at finding the best decisions. This area of science corresponds to prescriptive analytics. Mathematical programming should not be understood only as mathematical optimization. It also involves finite difference, or finite element, simulation models. The essence of mathematical intelligence modeling is based on the study of the human brain, based on neuroscientific studies. The result is the production of artificial brains. The symbiosis of the two methodologies, Hy considers it as complete artificial intelligence, that is, the union of generative pre-trained transformers and mathematical programming. It is called complete AI because the two methodologies, if they work in isolation, cannot solve the two problems, that of mental intelligence, and that of mathematical intelligence. Creative and math intelligence models. The research carried out by Hy concludes that, to model creative intelligence, it is necessary to use auxiliary modeling with models of any of the complementary intelligences. In the case of GPT models, they are already used to list possibilities for a scientifically appropriate design of experiments. Hy has chosen to work using models for mathematical intelligence based on mathematical programming, expecting the consumption of resources to be lower than in GPT-type models. To develop creative intelligence, it is necessary to understand the lives of creative scientists and their way of working, then it will be possible to try to model that process. Prior to the birth of computers, the scientist's routine could be summarized in iterative processing based on formulation of a creative idea attached to a theory, conducting experiments with the aim of validating the theory or finding errors to reject or to adjust the theory. If the experiments validate the theory, the creative process is over. Otherwise, the theory is adjusted, and new experiments are carried out. This process can be slow, due to the time consumed in each experiment, which can include setting up the experiment environment, which could involve complex processes, mainly when a laboratory with ideal conditions must be built. The creation of computers, which are the essence of mathematical intelligence, begins to transform this process, due to the possibility of computers in the process of experimentation. As the power of computers has grown, from the ENIAC computer to today's quantum computers, the involvement of mathematical modeling is playing an increasingly important role in the experimentation process, which can be carried out automatically following predictive and prescriptive artificial intelligence principles. An automatic experimentation process, carried out by a computer, once an experiment has been performed and evaluated, could follow the next algorithm. If the experiment validates the theory, the experimentation process is over. Otherwise, adjustments must be made to the theory or to experiments. For example, adjustments to the theory may involve variations to the equations. Adjustments to experiments may involve changes to the experiment environment. It is evident that with today's computational power, this process can be very fast, and the scientist can advance very quickly in his research. The experimentation process can be enriched with predictive artificial intelligence, which can learn from real-time experiments and the history of previous experiments. Prescriptive artificial intelligence can help improve theory by formulating and solving problems that require adjustments to the theory's equations. In this way, the scientist's learning is accelerated. The experimentation process can be enriched with predictive artificial intelligence, which can learn from real-time experiments and the history of previous experiments. Prescriptive artificial intelligence can help improve theory by formulating and solving problems that require adjustments to the theory's equations. In this way, the scientist's learning is accelerated. Another contribution of computer technologies to creative intelligence is digital twins. This aspect is linked to the need to carry out experiments that in many cases require the construction of a physical prototype. Before the existence and growth of computers, laboratories were physical and, in many cases, were built for an experiment. Today, digital twins can function as virtual laboratories and can be linked as input and/or output of mathematical artificial intelligence, eliminating the need for physical labs. Everything seems to indicate that creative artificial intelligence is ready to be implemented today. The diagram presents the work cycle, which has 3 stages. The scientist, together with a mathematical modeler, specialized in mathematical programming, produces a cyclical optimization model. The cyclic optimization model seeks to satisfy the conditions established by the scientist. If the result of the model is optimal, the scientist's hypothesis is accepted. If the result of the model is not optimal, the scientist's hypothesis is negated and the scientist must adjust the theory and experiments. Top questions about artificial intelligence. Below are the 3 key questions about artificial intelligence, according to each type of intelligence. Pattern recognition. Pattern recognition is typical of mental intelligence, and it is the activity that human beings perform the most. For example, they identify images of people, foods, hydroclimatic conditions, traffic conditions, texts, sounds, etc. It is a problem that is solved by neural networks that are the support of GPT, and in practice it is not solved with other technologies. From that point of view, it is a test passed. Real-life problem solving is a scientific representation that uses mathematical language to describe the part of reality that is of particular interest to a person. Understanding it requires formal training in mathematics, and in the science being modeled. This ability to understand and handle mathematics does not extend to all human beings. It is necessary to acquire knowledge and experience to correctly handle mathematical intelligence. Its development is directly related to the knowledge of formal mathematical laws, as well as computational and mathematical technologies. The decision-making process is the goal of any person or organization that seeks to make the best decisions based on their criteria. This is achieved through advanced mathematical programming, which, unfortunately, is managed correctly by few scientists and professionals. Since all beings must make decisions, there are methods of non-experts that do not comply with the mathematical laws of optimization. These methods are called meta-heuristics and can be considered typical of advanced mental intelligence. Given High's knowledge and experience in advanced mathematical programming, this is the only alternative considered for real-life problem solving. An example of a question to be solved could be: the IoT system reports that there are problems in the refinery X, which must be moved to maintenance. The optimal answer could be: the deadline for the normalization of operations is 3 days. Production adjustments should be made at the remaining refineries, based on the following 3-day production plan for each operating refinery. The pipeline serving the oil supply chain must be replanned according to the following 3-day production plan. This question cannot be solved with GPT. The actual process of mathematical modeling implies the use of cognitive robots that generate and implement complex optimization models. As explained above, the scientific discovery achievement process involves solving a cyclic optimization mathematical model to prove the theory and that the experiments are valid. In the research conducted by High, there is no direct model for creative intelligence. An example of questions about achieving scientific discoveries is: what is gravity and how does it work? Einstein wondered what it would be like to fall off a rooftop, or ride in a windowless elevator in deep space. Einstein concluded that gravity and acceleration are identical, meaning that they are massive objects that warp the fabric of space and time. Einstein understood that questioning is fundamental to learning and solving problems. If he were alive, Einstein would see a world in which questioning has become more important than ever. But you might also wonder why. For the most part, we still don't encourage questioning. Partial artificial intelligence is based solely on generative pre-trained transformers, GPTs, and is currently considered to be the only artificial intelligence. However, it cannot solve the following questions: real-life problem solving, achievement of scientific discoveries. Full artificial intelligence includes mathematical programming modeling, expanding the coverage of artificial intelligence. Together with GPT, the two methodologies can interact. It is evident that this approach is more developed than partial artificial intelligence, and can solve all questions. The extended human brain. The concept of an extended human brain through artificial intelligence encompasses the merging of human biology with digital technology to expand our cognitive, memory, and processing capabilities. This decentralized and autonomous way of acting is how the human brain operates and therefore must be imitated by any artificial brain. Each of these superorgans is made up of neuron networks, and lower-level superorgans. For example, the hippocampus has at least 2 functions and 2 areas, one that stores memory data and one that manages learning. This chain of organs and neural networks forms our brain. Since Ramon Y. Cajal, for more than a century, science has considered the cranial brain as the only center of neuronal complexity, relegating the rest of the organs to the noble task of fulfilling their functions. High's vision of intelligence is divided into 3 types: mental, creative, and mathematical, expanding the modeling power to include virtual organs that have a different way of acting and become part of the extended human brain. Industry 6.0 marks the transition to a paradigm in which technology not only automates, but also integrates biologically and cognitively with humans, and introduces living, self-regenerative, and deeply ethical industrial ecosystems. In just a few years, artificial intelligences can reside in a nano CPU, like an implant in humans. This will give rise to the true extended human brain that will include a digital organ that will be part of the human being. The human brain is made up of groups of neurons which, in turn, are made up of groups of lower-level neurons, or basic neurons, called by Hy the atoms of the brain. The central idea is to build an artificial intelligence that mimics the human brain, leaving aside the approach of representing the brain using a single network of artificial neurons. Structurally, the human brain is relatively simple, since it is made up of a single processing center. A case of coordinated parallelism in a brain is that of octopuses that have 9 brains, 3 hearts, and 2 memory systems. These brains are used to independently control each of its 8 limbs, allowing the octopus to move nimbly and react quickly to any threat. In addition, it has a central brain. This is one case, among many, of an animal with multiple brains and multiple hearts. Since we are talking about artificial brains, built by humans, we can extend the concept to an artificial brain with multiple artificial brains. The question is, which is the better artificial brain? One based on the human brain, monobrain, or one based on the octopus, multibrain? In the human brain, there is no coordinated brain, there are multiple organs that coordinate autonomously and independently. The artificial brain can take on any topology, since it is artificial. When all the models that make up a company are solved using the concepts of autonomous real-time distributed optimization, an artificial hypothalamus is obtained. Autonomy implies that models can act independently, without the involvement of a human command, and in real time, which can happen at any time. The concept of distributed optimization is associated with models that represent different agents, and that working as a team, solve a common problem, running in parallel. As referenced by Jeff Hawkins in his book A1000 Brains, there are multiple dimensions from which an artificial business brain can be viewed. In this case, the spatial dimension applies, where there is a model for each industrial facility. Based on the models to be integrated, and considering the magnitude, and the association between them, it is considered that the hypothalamus of a refinery business should be made up of 5 subsystems: oil refining and petrochemical, refinery industrial services, water treatment, multimode transport, and financial and fiscal. The algorithm that simulates the hypothalamus is assembled by Optex, the Hy's artificial intelligence, to generate mathematical programming solutions, using the models that traditionally make up a decision support system. Public GPT versus enterprise GPT. As technologies like ChatGPT and DeepSeek become household names, companies are increasingly exploring how generative pre-trained transformer models can revolutionize their business processes. However, there is a significant distinction between enterprise GPT and public GPT models that every executive should consider. There are 5 main differences. Public GPT, 5 main differences. Data security and privacy. These models operate on external servers, which poses risks when processing proprietary or sensitive information. Data governance is often a concern, especially in highly regulated industries. Implementation cost and operational costs. Lower upfront costs with subscription or usage models. However, unpredictable costs can arise as usage grows. While operating costs may seem lower, a lack of custom automation and efficiency improvements could result in hidden costs over time. Customization and control. It is based on public data and pre-trained insights. Adaptation to specific business contexts is limited, making it difficult to achieve full operational efficiency. Successful implementation, risk management, and return on investment. It is easier to deploy for general use, but enterprise adoption requires additional layers of development, which can introduce risks and dependencies on third-party solutions. ROI is often indirect and less predictable, as these models are not designed for specific business cases. Sustainability and long-term impact. While effective for immediate needs and experimentation, the sustainability of models in a business context is limited. The need for constant adaptation, compliance issues, and a lack of custom optimization all affect long-term strategic alignment. Public GPT versus enterprise GPT. While GPT models such as ChatGPT and DeepSeek offer an excellent entry point to generative AI, enterprise GPT represents a strategic leap towards the digital transformation of enterprises, as it is the basis for assessing whether the organization is ready for customized, secure, and scalable solutions that align with business objectives. For organizations looking to transform not only processes, but also generate a measurable return on investment, reduce operational costs, and build a sustainable competitive advantage, investing in enterprise GPT is a critical step. GPT cannot produce AGI, because it cannot solve all the questions that AI must answer. Generative pre-trained transformers. Public users of public GPT. Massification of ideas. A lot of ideas go into GPT, comes out one. GPT drives cognitive synthesis and the trend toward homogenization that occurs when using large-scale language models. In artificial intelligence, the synthesis funnel is the phenomenon in which many ideas enter and only one comes out. This is due to the architecture of GPT models. The process can be described as data compression. During its training, the model processes trillions of text fragments, ideas, facts, styles, and converts them into mathematical vectors or embeddings. Statistical prediction. Instead of choosing the right idea, the model calculates the answer with the highest statistical probability, based on the patterns it has learned, acting as a filter that discards the less common options in favor of majority statistical consensus. With this approach, creating a new idea is impossible. Noise removal. The synthesis process helps to control fragmented information, transforming disordered data into a coherent and structured narrative, but unique. Massification has critical side effects on diversity of thought and knowledge. Homogenization of thought. By favoring the most frequent patterns, AI tends to produce average or generic content, which dilutes individual creativity and minority voices. Creative illusion. Studies suggest that although GPT generates ideas quickly, most can be repetitive or similar, lacking the diversity that human critical thinking brings. Confirmation bias. The model is optimized to give answers that are satisfactory to the user, often leading to constant self-validation rather than challenging ideas with conflicting perspectives. GPT forgets that, for Henrik Ibsen, in scientific thought the majority is never right. The phrase "the majority is never right" is a famous statement, by playwright Henrik Ibsen, who argues that the dominant opinion often prioritizes comfort, conformity or popularity over objective truth. Ibsen asserts that conventional wisdom, or popular consensus, is often flawed and that progress comes from minority and independent perspectives. He argued that an enemy of humanity is the majority, which is made up of ignorant people, who cling to social lies, suggesting that they take a long time to be right, if ever. ChatGPT, what are hallucinations and why are they a problem for AI systems? Is the article written by Bernard Marr that has been taken as a reference. What is hallucination in AI? Hallucination in AI refers to the generation of outputs that may seem plausible but are incorrect or unrelated to the given context. Thus, GPT hallucinates information on which it has not been explicitly trained, leading to unreliable or misleading responses, which arise from biases inherent in the AI model, and/or a lack of understanding of the real world. The biggest problem with a hallucination is not knowing that you are hallucinating. This can be difficult to clarify, so it is necessary to know what it is not to hallucinate. The main formal hallucinations problem are erosion of trust, ethical concerns, impact on decision-making, and legal implications. There are several ways GPT can be enhanced to reduce hallucinations. Enhance training data, ensuring that AI systems are trained on diverse, accurate, and contextually relevant datasets helps minimize hallucinations. Red Team, AI developers can simulate scenarios to test the AI system's vulnerability to hallucinations and iteratively improve the model. Transparency and explainability, providing users with information about how the AI model works can help to understand when to trust the system, and when to seek additional verification. Human in the loop, bringing in human reviewers to validate the results of the AI system can mitigate the impact of hallucinations and improve the overall reliability of GPT. As GPT becomes more common, addressing the phenomenon of hallucination is essential. By understanding the causes of hallucinations and investing in research to mitigate their occurrence, the users can help ensure that GPT is used responsibly and effectively. Everything is ready for the artificial brain methodology to be extended to produce artificial general intelligence. The full artificial intelligence. The capacity of artificial intelligence can be measured by the number and type of questions it can answer. The methodology proposed by Hy seeks to increase the coverage of artificial intelligence. Hy considers that today artificial intelligence is generative pre-trained transformers and mathematical programming. This is the main theme of Hy's research. Full artificial intelligence is the next step in AI modeling and will allow you to see the world like never before. Albert Einstein said, "Imagination is more important than knowledge, because knowledge is limited, but imagination encircles the world." Remember, all science as it grows toward perfection becomes mathematical in its ideas. Alfred Whitehead. Thank you very much for your attention.